So guys, we're going to go through the eosio token contract. So this token contract is deployed on a lot of chains as the eosio.token account. So you can see it there. If we go to Block Explorer, we should be able to see this on EOS or Telos and verify it's there. So eosio.token. Here it is. So this contract here is quite important. It's the default system resource token, and this is used for accounting resource usage. That's the CPU, RAM usage, other storage types that are coming later in eosio, and net resource as well. So this is the token used for that. And we're going to go through it. So you're welcome to open it up on EOS Studio. You can check it out here, and then you can follow along there as well. So here it is, and you can see the header file here and the implementation here. So back to the header, you can see several things here. We've got, as we've seen before, a few libraries that we're including. We've got the definition of several actions. This is not all of them. Several actions. So this is used to create a new asset type. This is used to issue assets of that asset type to the first owner of those assets. And then this is the generic transfer function to send money, send some of those tokens from an account to another account. So those things we haven't seen before. So those things we have seen before, sorry. What we haven't seen before is this. So here we've got static asset get balance. So this is the definition of a getter function that's going to be used. So there is no notion of a transaction to call another account, but any contract can read the tables of another contract in the system. So instead of having to write out all of the code to read another contract, you can use one of these statically defined functions and call that instead, and that's just going to do the work for you instead. So this will essentially look at that token contract, and it goes and gets the balance. That will look at the balance table in the token and return how much tokens they have. So this is another one we haven't seen. This is defining an action wrapper. So this is a convenient abstraction that tells the code, that lets other code call the transfer function on this contract. So it means that instead of using the full action implementation here, so this is how we call another contract, this is how we send an inline action to another contract with code. We basically use this action wrapper here, so we have to get that transfer action wrapper defined here. We instantiate it with the account we're going to call and the permissions we're going to call it with. And then down the bottom we call that send function with the arguments we want to send here. Now if we didn't use this action wrapper, we'd call the normal action code, and that takes similar arguments. So again, it takes the permission level, right? So that's the same as what we've got here. It takes the account that we want to send the action to. It takes the name of the action. So notice down here we didn't have to define that. That's actually defined within this action wrapper. And it has to use the standard library tuple type to send those arguments. So this is also abstracted away when you use the action wrapper. Notice if you do send an action to one of the system accounts, you need to add the code permission. I'm not going to cover it in detail in this workshop. It's a little bit complicated and out of scope, But certainly there's a lot of documentation explaining it, and you're welcome to have a look at that when you get to that point in your contract development. So now in the token table definitions, you have two tables. This is the second one. It defines the balance of an account. So this is how many tokens you have. And what's interesting about this table is it does not have the only variable it has is the balance. It doesn't have the account in the balance, and that's because of something special. So it defines the balance that a user has, and the primary key is it uses the symbol code of that asset type. And I'm going to go into the asset type in a second. So down here it defines the type multi-index table that we're going to use to access this table. And lastly, it shows us two private functions that can be used in the transfer function. So this asset class has a few parts to it. So this essentially stores a very generic standard for an asset that has three parts. It has the amount of the asset, it has the precision, and it has the symbol code for it. So this is kind of what it looks like in real life. You might have an asset called EOS with 4 precision units, and the amount would be 1,000. So to actually create this asset, this is what it looks like. You instantiate a symbol, you pass that into the asset, so that symbol defines the code as well as the precision, so that means 4 decimal places in this case. To instantiate the symbol, and then you put the amount here when you instantiate the asset. And there's several member function. This is one of them. This is valid. It'll check that you've done that right. So now we can understand this a little bit better. This actually uses the symbol code, and the symbol code, if we saw on the asset, is stored as a uint64, and it has a member access function called raw to get that uint64. So remember, the primary key has to be a uint. So the way it looks up values in this table is by the symbol of the asset. And when we actually look in the account, we use the account name as the scope of the table. So I showed you before, scopes are a secondary index of table, and now the asset symbol is the search index. So this means we can basically do a double query on the table. We fetch the table, we look through the table by the scope, we use the account we're looking for as the scope, then we use the symbol as the search we look through. That means we can store multiple different asset types for the same user. And also it means that we don't need to store the account name every time for each row in the table. So this is saving RAM by using the account name as the scope of the table. Don't worry if that's a bit confusing. We're going to go through it a bit more. So this here is the transfer function. We're going to walk through this now. So it takes a name, the from address. It takes a name, who we're sending the asset to. It takes the asset and the quantity. So remember, this asset has 3 parts. It has the symbol, it has the precision, and it has the amount. And an optional memo that you can send with any transfer. It's not a big part of what's going on. So the first thing we do is we use a predicate to check that you're not transferring money to yourself. Otherwise, what's the point of the transfer? It's just clogging up the network. Then we check the asset itself. We check that the symbol precision is right. So, for example, the EOS asset on the EOS blockchain has 4 precision, 4 decimal place precision. So if you used 1.000 EOS, that would fail on the EOS blockchain for the EOS asset. It should be 1.0000 EOS. That's 4 decimal places. That's a common gotcha when trying to send arguments to the EOS blockchain. This here is a special wrapper, and that sends an action to another contract, this one. So this sends an action to the to address with the exact same action name and arguments as the action that this was called in. So this is a special type of action that's sent, labeled as a notification, and it can be received by the other contract. It's useful for notifying another account that an action has occurred that involved it, and it gives that other account the ability to maybe do some accounting or block the action if they wanted to. So this is what receiving that notification looks like. So there's a special compiler code here instead of using the action macro, and this tells the compiler how to describe this in the ABI and how to compile this. So this function here has to have the same arguments as the action that sends it. So it has to have the same arguments as the transfer function. And here we specify what actions we want to receive notifications from. We specify which account to receive notifications from and the action name that we want to receive notifications from. In here we are able to use wildcards, like you can see here. So if we use wildcards here for the action, for the account, and the action, it would mean we would execute this code whenever there was a notification from any other account. So then we do a few more checks. We check that the quantity is valid. We check that the quantity is more than 0. We do a check on the memo that it's not too long. Now we determine who the payer for RAM should be, and this is checked by who's authorizing it, or if the person who's authorizing it is not the to address, then the from address is used. So now in the transfer function it calls the subbalance. Remember, this is one of those private functions, so this is the implementation of that. We get the accounts table, right? And see here, this is the scope, right? So the scope, we use the, we actually use the from address as the scope here for this part. And this is looking at the accounts. This is to get around having that account in the table itself, which reduces RAM. Then we see if it has a value, see if it has a row for the particular asset by checking the symbol. Remember, this is what the primary index is created from, the symbol code. So if it doesn't find one, then it throws an error. Then it checks that, it checks the balance from that row, and if that row has enough value in it, if it doesn't have enough assets in it, then it's going to throw an error because you can't send money that you don't have. And finally, if that's all okay, then it modifies the row in the table to deduce that balance. Oh, I've just explained all this. So equivalently has to add the balance to the to address. So again, it looks up the account, again using the to address now as the scope. It then finds the value in the table based on the asset symbol that's being used. If that to address may never have been sent any of those assets before. So if that's the case, it adds that row to the table. If not, it modifies the rows and adds the balance to it. So there's one new part here, which is in that modify function, it uses this same payer. And this tells it to use the same person who was billed for RAM previously when this table was updated. So a few extra topics that we're not really covering so much in this workshop that you're welcome to check out. So this is the print function. This is useful for debugging. Within the tables, you're able to use any kinds of containers, certainly any standard containers that C++ allows, such as vectors, maps, lists, and other things. I briefly mentioned the dispatcher in one of the tutorials, but this essentially is the entry point for all functions. Have a look at it here. I have mentioned that you can create second indexes, and I haven't covered that at all. Check it out here. If you only need a few, if you only need a table, if you need one-time use variables in your contract, so for example configuration values or whatever, you don't need a table with multiple rows, and there's a simplified ABI. There's a simplified API called a singleton table that handles that a bit easier. And lastly, there's some error handling that's worth understanding as well. A few more examples if you want to check them out. And yeah, this is some more of the documentation that's available.